Hello guys, so welcome back. Today we are going to start the Leetcode question that we have, and we are Funda and you're watching on YouTube. So let's understand today question. Okay, so today we have question that is 875 and question saying that Koko eating bananas. Okay, so here is a Koko, right, and he is eating banana, right. From here a piles of banana, and here is the guard, right. So what do you will understand? So let's read the question so we will understand easily, right. So Coco loves to eat banana. Okay, so as you can see here, he is loves eating banana, and there are n piles of banana. So there is n piles of banana, and the ith piles has piles of banana, right. So if there is we can say ith pile has a piles of banana. Okay, so there is a lot of piles you can see here, right. There is a piles of banana. So from here he can take one, if he'll take a ith pile, so he has some hand in some hand, right. So the guard have gone and will come back in some hour, 8 hours. Okay, so Coco decide her banana per eating hour speed of k. Okay, so each hour she chooses some piles of banana and eat k bananas from the piles, and if the piles has less than k bananas, right, so she eat all of them and will not eat any more bananas during this hour. So Coco likes to eat slowly but still want to finish eating all the bananas before the guard return. So return the minimum number of minimum number integer, you can say k, such that she eat all the bananas within this hour. So if you will notice that there is a array of you can say piles, right, bananas, and there is given some each hour, if that within that hour, if the guard is not returning, he is eating banana with the speed of what, k, and she want to eat piles of banana, right. So she eats k banana from the piles, right. If the banana has less than k banana, right, if k bananas are less, right, means she want to finish all the bananas, right, and will not eat any more banana during this hour. Now she is saying Coco eats slowly but still wants to finish eating all the bananas during the guard return, before the guard return, right, and that k we have to return, and she can eat all the banana within that hour h. Okay, so as you can see we have given these piles, right, and these are the piles, you can say value, right. So I0 we have 1 2 3 we have, right. So 4 piles we have here, and h we have given is 8. Okay, so if you'll talk about we have to find the k, right. So this is nothing but our we have to minimum integer k we have to return, so this k. Okay, so h is given 8, right. So how many c can eat, right, a speed k we have to return, right. So how many she can finish, right, that hour, right. So that we have to return. Okay, so before jumping to this answer, right, what we can do, we will see the you can say approach, right, and then we will come back to here and we'll try to explain this one. Okay, so let's this question has been asked in Faang, right, and top all product based companies. I have not listed all other companies, right. So this question is very important, you can say. This question is related to arrays and array and binary search, right. So you can implement through binary search, right. Similar questions we have is minimum max distance to the gas station. If you have already aware with that this question, so you can find this one. Maximum candidate allocated to k children, minimize a maximum of product distributed to any store, and frog jump you already knows, right. So if have gone through, you can try with that approach. Okay, so now what we can say, let's understand the approach in which the very naive approach we will use, that is the brute force. Okay, and we'll try to implement we'll try to understand this one. So if you'll talk about this problem, right, so in this problem Coco is giving n bananas of Coco is giving n piles of bananas, right, and that represented by an you can say integer array. There is some integer, you can say n, right, n length of integer we have in the array, you can say. So C eats, you can say, banana at a constant speed. For example, X banana, we can say X banana we have, right, bananas per hour C is eating. X banana we have, and this is the time we have in which C is eating X banana. So the time taken to eat a pile of banana of Y bananas, right? Let's suppose Y piles we have, right? How many have? Y piles we have, right? So Y piles of banana, we can say, let bananas. So in that case, total banana is what? We can say total is Y by X, right? Because see, in each hour C eats what? C eats X bananas, correct? In each hour. Now we have Y piles bananas. So how many C will eat? How many time it will take? Time to eat. Time to eat, you can say, is Y by X, correct? So I am saying that if C has a constant speed of eating banana, right, and if there is X banana, right, if there is X banana, so C is eating X banana in H hours, okay. So the time taken to eat a piles of banana, Y piles of banana, and so the time will take what? Y by X, got it? So after rounding up to the closest integer, you can say, for example, if C eats 3 banana per hour, let's suppose if C is eating 3 banana in each hour, okay, in 1 hour, or you can say, okay, so it takes her 2 hour to eat piles of 4 banana, correct? So if you'll talk, so 1 banana it will take what? 1 by 3, right? So if we will take how many banana? For 4 banana, right? So it will take what? 4 by 3 it will take, right? Let's suppose, because it will multiply that directly, right? That one. Or you can say, or if you talk about directly, so it will, you can say, if 3 banana takes 1 hour, 3 banana takes 1 hour, right? So if you talk about 3 banana, right? So a pile of 4 banana will take what? 2 hour, correctly, okay. So the first constant of the problem is to Koko has to eat all the piles within H hours, okay. So where H is no less than the number of piles, and we can imagine that with a fast speed Koko spend 1 hour on each piles, right? 1 hour on each piles. Therefore we can always finish all piles within H hours. So let's call this a kind of speed is workable speed, right? So if or let understand, if we are eating a speed at which Koko cannot eat all the piles to workable unworkable speed, right? However, we have not we have another constant that Koko would like to eat as slow as possible. Therefore among all the workable eating speed, we need to find out all the minimum one, right? That's why I have going to use the brute force approach, in which we will see how do we calculate overall time to for the Koko to eat all the piles, right? Means our thinking to do this approach is how do we calculate the overall time, right, for all the Koko, for Koko to eat all the piles, sorry, okay. So let's understand, we have the first piles we have, second piles we have, third pile we have, and these piles we have. You can name them 3, 6, 7 and 11, right? So these are piles we have, right? And here Koko, I eat 5 banana per hour. Let's suppose Koko is eating 5 banana per hour. So and guard will return in what? In 8 h equal to 8 hours, right? So how will how much Koko will eat, right? So how we can calculate overall time for Koko, right, to eat all the piles, okay. So let's understand, if Koko is here, he eats 5 banana per hour, right? So now he finishes this one, let's suppose, right? So in 1 hour he is eating what? In 1 hour he is eating 5 banana, right? In 1 hour. Now how many banana we have here? 3 banana. So in 1 hour he is eating 5, right? So in you can say now we have 3 banana, right? Let's suppose how I am saying, in 1 banana he is eating in 1 hour, right? So 1 banana he is eating by 5 banana, 1 by 5, right? 1 banana. So now we have 3 banana, so we will have what, 3 by 5 that we are talking about. Okay, that's why it is coming like so. The time is what, time will become 1, and that's why we have the time 1. So total time is what, 0 plus 1 is 1, correct? Now we'll move to next one, right? This is finished, right? This is finished. Now we will coming to this one. Okay, so previously what we have 1, total time is 1, right? Now we have what, 6 by 5, because in 1 hour we are eating 5 banana, right? So for the 5 banana means we are eating one within 1 hour, so 1 banana is for 1 by 5, and for 6 banana what will happen, 6 by 5, correct? So for the 6 by 5 we will get what, 2 hour, because it will become what, we have to take upper limit, right? And so it will come 1 point something. Okay, 1 point, let's 2 it will come. So we have to take what, upper limit of this value, and so we have to take 2, and the previous value is 1, now current value is 2, so it will become total time is 3. Next time if we'll this is done, right? So next time what will happen, previously total time was 3 we have, right? Now we have this is done, this is done. Okay, now we are coming to this one, 7. Now similarly for 1 banana we have to 1 by 5, right? So for 7 banana we have to 7 by 5, correct? And if you do the 7 by 5 it will become 2 for the with the upper limit, right? And so we have to do 3 plus 2 equal to 5, so total 5 we have. Now we will move to the next one, that we will reach to this one, and these are done, okay? So 11 by 5 similarly we'll get 11 by 5, that will come 3, 5 plus 3 equal to 8. So total time is less than or equal to 8 hours, right? So either it should be less than or equal to 8 hour, okay, correct? And so 5 banana per hour speed is workable speed, you can say, correct? I think you understood, right? So this was the purpose of saying that I eat 3 banana per hour, and God will return in age equal to 8 hours. That will fine for him, okay? And that's why if we'll talk about this one, so it will work for you, okay? Now think about this one, that one he eat 3 banana per hour. Previously he was eating what, 5 banana, now he is eating 3 banana. So when he is eating 3 banana per hour, okay, and time is same, right? Now we will move to 3 by 3, it will become 1, 0 plus 1 1. Similarly it will move to second one, now it will become 2, 1 plus 2 equal to 3. Similarly we will move to third piles, 7 by 3, 3 plus 3 we get 6. Now we will move to this one. Now it is coming what, 6 plus 4 is 10, correct? And 10 is not less than equal to 8, correct? And that's why it is saying the time, total time is larger than the 8 hours, right? So 3 banana per hour speed is not workable speed, right? 3 banana per hour is not a workable speed. That's why we are saying that the meaning of workable or not workable, okay? I think you have understood this one, right? So let's understand the final question that we should ask to ourselves, right? So does the order by which Koko eat affect all the times, right? So if we'll change the order of this, any of those order, if we'll change, so does the order by which Koko eats affect the overall time, right? So we are talking about to understand the workable non-workable speed, right? So does the order by which Koko eats affect overall time, right? So the answer should be no, right? Why? The order does not matter, because Koko will stop eating for the rest of the hour. So even if there are no more bananas, right, left in the current piles, therefore the time she spend eating a particular piles, right? Let's suppose if we'll talk about so if she is eating a particular piles, right, and it is taking what, let's suppose current time, okay, we have some current time, right? So current time is what, number of banana, right, number of banana by some, there is some speed, right, there will be some speed. So if we can say if there are no more bananas left in the current piles, right? So therefore the time she spent eating a particular piles in a given current time, right, it is number of banana by their speed, right? Regardless of the order of the piles in her eating, plan X denote some selling value, right, not the down value, right? We have to take some its selling value. If you remember, selling of the some value will come. So let's suppose some value is like this, so that selling value we have to take, right? So order of the piles in her eating the some x let's suppose x plant, right? So that will come some value, right? And that value should be in selling value, right? So we can include that as long as the eating speed is the same, right? The order of the piles by which Koko eats does not affect the total hours. That is the you can say quick answer. You can say answer is no, and so we can keep the array as it is for convenience, right? So the brute force approach is to try every possible eating speed, and we have to find the smallest workable speed, right? You can for that. So the brute force approach is to try every possible eating speed to find the smallest workable speed, you can say, right? So we have to find the workable speed for that, and this is our approach on the brute force. And the brute force is to try every possible eating speed to find the smallest workable speed, right? So starting from the speed 1, what we will take, we will always take a speed equal to 1. We have to take the speed equal to, we will start the speed equal to 1, and then we will increment it by 1 each time. We will do plus 1. We can increment each time. We will find a speed at which Koko can eat or all speed, all piles within the h hour. So if there is x piles we have given, let's suppose, right? So we have to finish that within the given speed we will take, and if it is not finishing, we will increment this one. We will do plus 1 and will increment the speed. I think you understood, right? So after incrementing each time 1, right, what we will do, we will find the speed at which Koko can eat all piles within the given hour h, right? We have given h hours, right? And within that we will find. So the first minimum speed we have to return. I think you understood, right? So we'll check with the speed 1. This will not work. X speed is what? Let's say speed is 1, speed is 2, speed is 3. On this speed it will work. Okay, so we will say maybe this will also work. So this not required to find this speed. This is unworkable speed like this one, because this is working fine for us, right? This is okay. We will not go to find more speed. More speeding find we don't require. We will find only this speed, that is the minimum speed we have to do. And for that, if we'll talk about the algorithm, as we will understand, is always take the speed at 1, right? This is we are doing for the, we can say brute force, right? So we'll start from the speed 1, and similarly we'll increment the speed, right, by 1 always. Okay, and or you can say a speed plus 1 equal to speed, we can say, and then we will start over the speed 2 again, right? And we know this is the first thing we will do. And at the given current speed, calculate how many hours Koko needs to eat all bananas, right? So if the Koko cannot finish all the piles within the h hours, we have to increment. That is the meaning, right? And if the Koko can finish all the piles, mean that is the case, right? So how we will find that Koko will able to eat the banana or not? So he already knows. So this was your given times, right, h, and if this is not satisfying this one, right, so this is not workable. Unworkable, you understood, right? So in the previous example you have seen that how many hours we get, we have total time it will take what, 8, and we have given time is also 8, that is equal to this one. So in this case we'll say this will work, right? And so that you can find for that one. Now if we'll talk about if Koko can finish all piles within the given hours, we will go to the step 3 and we'll say this is our answer of the speed. Okay, so now you have understood, right? So similarly if we'll talk about the previous one, right, let's go to here. So previously we have taken this one, right? No need to understand much, because we have already understood. So this h is given, we have given what, 8 we have given, right? So what we will do, first we will start with speed is what we have given 3. Okay, so now a speed is what, let's suppose we will take a speed equal to 1. Okay, so in in 1 hour will take 1, right? So 3 hour will take 3, then we will take 6. So it will not work, right? Here it is become 9, right? Next we will take a speed equal to 2. So in 2 hour 1 by 2 will do. So 3 by 2 it will become 6 by 2 it will become. If you add this one like this, so it will also not work. When you will take a speed equal to 4, okay, when you will take a speed equal to 4, so what will happen? It will become in 1 banana to eat, it will become what? You can say 1 banana it will become 1 by 4, right, in 1 hour. So for 3 it will become what? 3 by 4, so it will become what? 1. For 6 by 4 it will become what? 1. For 7 by 4 it will become what? 1. And 11 by 4 it will become 2, and here 2, sorry. Okay, so if you do the sum, 1 plus 1 it become 2, and plus 2 is 4, and plus 2, 4 plus 2 is 6, right? So it will finish this one, right? And that's why the answer is what? 4. You can take your time and to implement this one. Similarly, if you'll talk about another 2, right, examples, so you have to find the speed, right, at what speed we can do. So if you'll do the 30 as a speed, right, so it will cover the hour 5. Similarly for this one, you take your time and do, so it will work. Let's understand the coding part, and for that we have to go to the browser section and we have to implement this one. Okay, so we have already understood the, what we can say, algorithm. So we have to start the speed at equal to 1. Okay, I'll increase the font so that okay, now what I will do here, I will start from here. Okay, so what I'm saying that we will start the speed first, right? So speed is equal to what? I will start from 1, right, and then each time we will increment if we are not able to find. So we will make one loop, and we will say if loop is true, till that we will increment. Okay, till that we will move, right? And we'll say there is some hour. Let's suppose I'll take some int, and there is a hour, and we'll say a spend. We have hour spend, and that is we will start from 0, because see, hour spend stands for the, you can say, total hour of Koko that he has spent with the given time to eat, given time to eat the banana with that speed, you can say. That will take this one. Okay, and then we will take what? We will iterate over the piles, and we will calculate the hour spent, and we increase the hour spent by you can say selling value piles by speed, right? So how we'll do that? For that we have to go to the for loop, and we'll make one int pile will take from, this is your piles, and we'll take from what? Piles, right? And how we'll do that? We know that we have piles by speed, right? So this is our hour spend, right? This is our hour spend, and this hour spend will take what? You can take math selling value, right? So I'll do plus equal to, and we'll take math function. We have math dot, there is a sell value, it should come, yeah. And for that what we have to pass? The selling value, piles, right? You can say pile by we have some speed, right? So we'll pass some speed, and this will happen, this will return. So this may come in you can say double, so we should typecast this one. So we'll take double, right, double, and this will return you the spend hour, right? And once we have the spend hour, we'll check if the hour spend, right, this is hour spend, if the hour spend is greater than what? Your given hour, means this is not working, right? We have to break there, we have to break here, we will not continue this one, right? So this loop will complete, right? Once we will have our spend. Now we will check if the Koko can finish all the piles within some h hours, you can say. So if therefore we will return a speed, otherwise we will check otherwise what we will say, we will we will consider a speed increment by 1, and we will repeat the previous iterating again. Okay, Otherwise what we will do, we'll make a condition. Let's suppose what we'll do, we'll say if, make condition, if hour spent, we have some hour spent, right? So this hour spent we have, and if hour spent is less than equal to given hour, that is h, right? So in that case means we have got our speed, we should return this minimum speed, right? So I'll say this is our speed, and if not, right, if you can say else, otherwise what we will do, otherwise speed increment by 1 and repeat the previous iterating again, right? And for that what we have to say, speed equal to and equal to, no, you can say 1. So before that we have to make plus, so that it will increment each time, or you can say speed equal to speed plus 1 also, this will work. Okay, I think this should work. So what I'll do, I'll try to compile this one first. Let me submit this one. Okay, so actually it is giving time limit exceed, right? So what we will do, we will continue this one to make time complexity as better than this one. Okay, so it will take your time complexity. See, the time complexity for this one is if we'll talk about TC, right? So TC will take what, if we'll take what we are taking here, we have piles, right, and h we have given, right? So if we have n piles, let's suppose we have n piles, so we'll take o of what, o of n, let's suppose I'll take n is length of the input piles, right, and m is the upper bound of the piles, let's suppose. So we'll say nm. Okay, and for the space sc equal to o of what, we'll take 1, because see, we are not taking any extra spaces for eating speed, right? We iterate over the array and we will calculate total our Koko spent, right? And which is a constant speed, right? And you can say which cost constant space, we are not storing anywhere else, right? Therefore overall speed is complexity is O of 1, right? And why we have taken this one, sorry, why it is coming like this, yeah. And if we'll talk about the space complexity, so we have taken n is a input length, right, and m is the upper bound of the speed, right, and upper bound of the piles, you can say, and that's why we are getting this one. So for each eating speed, right, we iterate over the piles and we'll calculate the overall time, which takes O of n times, right, for the that one. And before finding the first workable speed, right, we must try every smaller eating speed. Suppose in the worst case scenario where the answer is m, right, we will we have to try every speed from 1 to m, right? So there is a total of m iteration over the array, right, for the minimum you can say speed to find, right? And to sum up overall this one, so we have to take O of n m, right? And the best case scenario, you can say O of n, right, if this is the one speed. Now what we will do, we'll try to do this same implementation using the binary search, right? So if you have already understand this one, so it's fine. Otherwise what we will do, let's continue this one with the you can say binary thing. Okay, so let me go here. What I'll do, I will remove this one from here. Now let me submit this one, so that I will have this one. Yeah, I think I have already submitted this one, right? Now what we will do, I'll take the speed from here to here. Let me remove these things. Okay. Okay, so we are here. Now think about the implementation, how we'll do this implementation. Okay, so we have n bananas, right? We have n banana per hour. So if not, we'll do n plus 1 banana per hour. And if n banana we have, we don't have to do n minus 1 banana per hour, like this. Because in the previous approach, what we have tried, every smaller eating speed, we find the workable speed, we have looked for more efficient way to locate the minimum workable speed, right, eating speed. So we can recall how we can calculate the total time for the Koko to finish eating all the piles in the approach one, right, that we have seen. So we can observe two laws. The first is if the Koko can eat all the piles with the speed n, she can also finish the task with the speed of n plus 1. Okay, so with the larger eating speed, Koko will spend less or equal time or on the every piles, you can say. Thus the overall time is guaranteed to be less than or equal to the speed of n. And if the second is saying that if Koko cannot finish with a speed of n, then she can finish the speed of n minus 1 either. So n plus 1 on n minus 1 either, you can say, right. Two laws we have, and within a smaller eating speed, Koko will spend more time or equal on the every piles. Thus the overall time with the greater than or equal to the that speed. So what I'm talking about, let's understand here so that you will understand, right. So first of all, we'll take our two boundaries, right. For the boundary left and left, we will start from 1, and right will start with the max 1. Okay, so I'll take int left. Okay, so left will start from what, I'm talking about 1. Then I will start right. This is our int and this is our right. Right is nothing but what, it is also 1, right. But we have to initialize two boundaries of the binary search. Left equal to 1 and right should be the max of piles, right. And for that, what we have to do, we have to find the max 1. How will find this max 1? We know that we have to move to the piles, right, and we will have int pile, and from the pile, how we'll get from the piles, we'll iterate this like this, and we have a math function, right. So I'll take right equal to, there is a math dot, there is max, right, math dot max, and then we'll pass two things. The first we will pass to our right, and another will pass piles. Okay, sorry, pile. So we will get our left is at 1 and right is at max. Okay, now what we will do, we'll make a while loop. And we'll check if left is what, less than right. Let's suppose if left is less than right, then what we will do, we will say get the middle index between the left and the right boundary indexes. So our spend stand for the total our Koko spend, right. So how we'll do that, we'll check I was talking about, we have to find the mid, and we'll say how we'll do left and plus, this is nothing but our binary, right, binary search, and we can do by 2, right. And we can, for the safer purpose, we will put into our braces. Okay, now this part is done. What we have, we will have our mid, right. So we have got the middle index between the left and right boundaries indexes. Now we have to find the hour spent, that is for the total hour of the Koko spent, right. So if I'll take int, and that is our underscore spent, this is our hour spent, and that is nothing but our 0. Got it. Now we have to iterate over the piles, right. Now we have to iterate over the piles and calculate our spend. Okay, so we will iterate over the piles and we will calculate our hour spend. We increase the hour spend by selling value, right, that we have already did, right. So what I'll take, I'll use this loop because we have to move on to this loop only. Okay, so we are getting the piles. Now we have to update here. Now we will take our spend, and we have, and then we will find our we did in the last approach, we did plus, then we have to do the same math dot, there is a selling value, right, selling value, and from there we will use what, first we will type past this one, right, in the double and a speed by piles by speed, right. I have pile by speed, right, like this we will do. Now we have what, pile by a speed each pile by their speed, and with that which is called a selling value, that will come onto our spend. So total time we will get update each time. Okay, this is done, right? So one thing I can do to format this one. Now we will have our spend. Now we'll check if the middle is workable speed, right? And we'll cut the search space by half. So we should check if our spend, right? If our spend is what, less than equal to h hour, okay, then what we will do, we'll say we have to cut the half, right, using the mid. Now so the left right part is gone, right? Half right part is gone. Search half space, no need to do the half search, right? Now if not, that is not the case, then what we will say, otherwise we will say left half part is not need to search, so cut the search space by half, and this is our mid, you can say. Okay, mid plus 1 से start करेंगे, mid plus 1. This part is done, right? Now what we will do, once this is done, while loop is done, once these are done, right, you have your right, you can say. Now you should return your right. Okay, so once your once the left and right boundaries coincide, you can say, we will find the target values, right? And that is the middle workable eating speed we have, and that is our eating speed. Okay, let me try this one and then I'll come back to here. Okay, so this is not working. Why? We have taken math or selling value, and we have taken the speed, right? And pile by, sorry, not pile by, mid, we can say. Okay, mid value. Yeah, let's submit this one. Yeah, this is working fine, working for me, right? Let's understand this one first. We'll try to understand this one code, right? So what I have taken, first we have taken left, then I have taken right. Now we have to find the right should be at the max of the you can say max of the piles, right? And for that we have to move on to the loop, and then we have to find our right. Now once you find our right at the max, what we will do, we will make a loop, right? And we will have to find the mid as each time, and our spend, for the our spend, what we have to do, you have to get all the selling speed, right? How? Piles by pile by mid, right? And you will get our speed. So we have to update each time so that you will get all the speed, total speed, right? Total time spent. And if our is if total spend is less than this one, so we have to cut our half of the right search space, and we will consider from the left to mid. And if not otherwise, so we have to cut left half search speed. Okay, left half search space, and we'll consider only the right sub part, and otherwise we will return right, because see, we why we are returning right, so we have our you can say target, right? And once the left and right boundaries coincide, right, we will find the target value, and that target value is what? The minimum workable eating speed, that is at right. Now this is done. Let's suppose what we are talking about. So if the previously we have understood, right, n we have taken as an input, and input of the array piles, right? And m is the number of you can say banana in a single piles from the piles, right? So what will take, tc is equal to time complexity is become what, o of there is n is a number of you can say in the length of input array, and there is a log m will come for you can say m is the number of banana in a single piles, right? And similarly with the space complexity sc, it will become o of what, o of 1. And why we are taking this as like this one, right? Because see, time complexity is O of 1, O of n into log m, because the initial search space is from 1 to m, it takes how many time? Log m comparison to reduce the search space to 1, right? So in the binary, you know that log m it will take, right? And so for that, to find the, you can say, initial search space, right, from 1 to m, right, what we have to take? We have to take log m comparisons to reduce the search space to 1, right? And for each eating speed, right, so the speed should be middle, right? And we traverse the array and we calculate the overall time Koko has spent, right, which take O of n, right? O of n, you can say traversal, and for that we have to take O of n into log of m, and that we will do the sum, so it will do n into log m. And for the space complexity, right, we are not taking any extra spaces, and for each eating speed middle, we iterate over the array and we calculate the total hours of the Koko that spends, which cost constant space, right? So overall complexity is of 1, right? So thank you guys, thank you so much for watching the video till now, and if you like this video, please hit subscribe so that you will get more videos like this, right? And please subscribe for more videos so that you will get more updated videos. Thank you so much guys, thank you so much.